let me just say that next exam, my advice to you to do well on next exam is to not only to try to do the homework immediately once I'm done with the material, but also to read ahead of time. Even if you do not understand what you're reading, read the section. Okay? You don't have to understand. Just read it and try to get exposed to what they're saying about the section. Do all the homework and read. Okay? That's one way to survive next exam. Exam number 3 is known as the exam that is the hardest in this class. Okay? Why is that? Well, it's not because it's that long, because it's only 6 sections. 2-7, 2-8, 3-1, 3-2, 3-5, and 3-6. 3-5 is not the easiest section because you have several things to do for one given problem. Actually, you have 6 steps to show for one given problem. We'll take the time to explain everything, and you will get exposed to everything. But your part is very important, okay, to be successful in this next exam. 2-7. I believe section 2-7 is dealing with inverses of functions. So let me just give you a piece of note on that. All right, let's start it like that. Let f and g be 2 functions if the composition of f of g of x is x, and also the composition of g of f of x is x, then it is safe to say that the functions are inverse of each other. And f and g are inverses of each other. Now, it's not only if this one is true, but also this ought to be true also, because you may have x here, but you don't have x on the other way around. It's both. Okay, and then you can claim that they are inverse of each other. So if g is the inverse of f, then it is denoted as f inverse of x. And I put in parentheses so you'll know this is f inverse. That's how you read it, okay? Not f to the power of -1, it's f inverse of x. That's how you read this thing. The domain of one is the range of the other. The domain of f is the range of f inverse. The range of f is the domain of f inverse, and vice versa. That means the other way around is true also. Next, for this section, we need to know how to find the inverse of a function algebraically. How do we find the inverse of a function algebraically? To find the inverse of a function, f of x, use the following steps. Number one, replace f of x by y. So wherever you see f of x, you replace it by y. Number two, interchange x and y from step number one. Number three, solve for y from step number two. Number four, replace y from step number three by f inverse of x. That's how you would find the inverse of a function algebraically. While we're there, let's give you a piece of note. If you're given a graph, they may ask you to state whether or not this graph has an inverse. Given a graph, they may ask you to state whether or not this graph has an inverse. At that, you will have to pass what we call the horizontal line test. The graph of a function f has an inverse if no horizontal line can intersect it into more than one point. If you cannot find a horizontal line that would cross into 2 points or more, into more than 1 point, you say, well, that graph has an inverse. And we'll leave that to the exercises. Okay. So let's look at the exercise from that set. If you don't see your name in this list, then the chances are you've been dropped from the class, or I'm about to drop you. Come and see me after class, please. Okay? And then also sign for today and Monday, if you were in class on Monday. All right? So sign 2 slots. Okay. Form 2-7 will do the following. Some of the problems in here are very long. Like a problem like number 28 is very long. So when we get to that problem, I would advise you to drop pencils and pay close attention. These are the problems we'll do from this section. I have to ask that. What happens with number 2 that I did in class and I said that was going to be on the test? Most of you missed it. When you get a chance, look at number 2 and go back to the section that is involving with difference quotient. You will see that problem in your notebook. Exact same numbers, everything. Exactly. Same thing. Anyway, take some time to look at your notes, okay? Page 290. before, f of x is 4x plus 9, while g of x is x minus 9 over 4. The question here is to check out and see whether or not these two functions are inverses of each other. Now, how would you know they are inverses of each other? Well, you have two steps to show. The first step is to show that f of g of x is exactly x. Show that the composition of the two functions is x, both ways. So we're going to go this way, and then we're going to go the other way also. That is f of, we're replacing g of x by its value, which is this expression here. X minus 9 over 4. Now, how does f transform anything? Well, f transform anything is 4 times whatever you see inside plus 9. 4 times what you see inside plus 9. So we'll have 4 times whatever is inside plus 9. And now on the inside of parenthesis, we put whatever we have inside of parenthesis here, which is x minus 9 over 4. Now, observe that because of the 4 outside and the 4 on the bottom, we can simplify this expression. So what is left? Well, we have x minus 9.
That's all right. It didn't break.
Plus the 9 that was outside.
I hope it didn't break.
So, and that we have negative 9 plus 9 is what? 0. So we can conclude safely that the composition is exactly x. That's the first way around. Now, we find that the composition here like that is good based on the definition that I gave you. The other one ought to be x also in order to claim that they are inverses of each other. So part B, we need to show that g of f of x is also x. So g of f of x, which is 4x plus 9. Now let's go back to g and see how g transforms anything. Well, it's whatever you see inside minus 9 over 4. Whatever you see inside minus 9 over 4. So that's what we'll do. I know this is a break. So, it's whatever we see inside minus 9 over 4. So this is 4x plus 9 that we had inside. It's whatever you see inside minus 9 over 4. Now you combine on the top. When you combine on the top, what do you have left on the top? 4x. So we have 4x divided by 4, which is x. So okay, we do find out that this is x also when you go this way. At that, you can conclude that f and g are inverses of each other. And that's what you were asked to do for number 4. Questions? Yes?
So they're only inverses when both are exactly x.
Yeah. It cannot be 2x. It cannot be 3x. Even if both were 5x, it would not be inverses. They would have to be exactly x. Not with a coefficient, not with a denominator, nothing, x. Then you can claim, yes, they are inverses of each other. All right? Unless I had something to say. Okay, so next we are going to move on to number 10. Number 10 is the same question. Same question but different functions. Just for more practice, that's why I picked 2 of them. So we have f of x equals to the cube root this time. The cube root of x minus 4. And g of x is x cubed plus 4. That's what we're dealing with. Both questions still the same. So part A, we need to find f of g of x and prove that this is x. So this is f of g of x being x cubed plus 4. Next, what do? Well, we're going to apply that to f. And how does that work? Well, it's the cube root of whatever you see inside minus 4. The cube root of whatever you see inside minus 4. So this is going to be the cube root of whatever is inside minus 4. What was inside? Well, inside we had x cubed plus 4. When you combine like terms, what do you have left under the radical? X cubed. Now, for this problem, there are two formulas that we need to know. We need to remember, I should say. If you have the n roots of a to the power of n, you just divide the exponents together and add that, you get a. Also, if you have the n roots of a to the power of n, this equals to a. These are two rules from algebra that we need to remember to do well in this problem. So with that in mind, what is the cube root of x cubed? X. So we conclude that f of g of x is x. Well, that's the first one we need to prove. The second one is the other way around, g of f of x. Let's see if this is x also. That is g of the value of f of x, which is the cube root of x minus 4. That's the value of f of x. We're going to apply that to g. And how does that work? Well, g transform anything by cubing everything inside plus 4. Cube whatever you see inside plus 4. So we will cube whatever we see inside plus 4. And what was inside? The cube root of x minus 4. What is the cube root of x minus 4 cubed?
X minus 4.
X minus 4. That's the second rule that I put on the board. So that's going to be x minus 4 without the radical plus the 4 that was outside. And when you combine like terms, what do you get? X. So since we do get x this way also, we can safely conclude that the functions are inverses of each other. So you say f and g are inverses of each other. Questions? All right. That was number 10. Next, we'll move on to number 20. 20. F of x equals to x minus 1 cubed. F of x equals to x minus 1 cubed, and the question is to find the inverse. Well, whenever they give you a function and they ask you to find the inverse, you have to go algebraically with these 4 steps that I gave you. To find the inverse of a function f of x, use the following steps, the following 4 steps. So what's the first step?
Replace f of x by y.
Replace f of x by y. What's the second step?
Interchange x and y.
Interchange x and y. That means wherever you see x, you replace it by y. Wherever you see y, you replace it by x. That's what we call interchange them into each other. So this is x equals to y minus 1 cubed. What's the third step?
Solve for y.
Solve for y from the second step. That means I will always encourage you to copy the second step over. Whenever you're getting to that point, copy the second step over. Then you solve for y from there. Now, how would you solve for y in here? Anybody? Cube root. Find the cube root of both sides. That's how you would get rid of the exponent outside here. It's the cube root both sides. If it were to the power of 4, you would find the fourth root of both sides. If it were square, you would find the square. So you do that to both sides so you can find. So this one here is the cube root of x equals to y minus 1. However, if it were like an even number, you would have to take the plus or minus. Okay? Since it's an odd number exponent, that's why you just take the positive cube root. Remember that? We did that from section 1.5. All right. So when you're solving that, you just put the 1 on this side so to get y by itself. This is the cube root of x we currently have. we have y here. We need to put 1 on this side here to conclude the problem. Observe that the 1 is not under the radical. The 1 is all by itself. That's why I closed the radical so you would see that. Once you get y by itself, you're ready to write step number 4, which is to replace y by f inverse. So we say f inverse of x is the cube root of x plus 1. And that's the inverse of the function. Now that was only part A of the problem, okay? That was part A of number 20. For part B of number 20, you were saying, they say, well, if this is the inverse, that you claim to be the inverse, prove it. Prove that this is the inverse. And how are we going to do that? Well, we're going to find the composition of the two functions. The function and its inverse. If it gives you x both ways, then you say, yes, it was the inverse. If not, then you had a problem with the inverse. Okay? Just like what we did for numbers 4 and 10. They asked you to do that for part B of this problem. So let's go ahead and do part B of this problem. Part B, you have two things to show. First thing you need to show is to show that f of f inverse is x. Show that the composition of the two functions is x. That is f of the inverse, which is the cube root of x plus 1. Now, how does f transform anything? Well, f transform anything is whatever you see inside minus 1 cubed. Whatever you see inside minus 1 cubed. So it is going to be whatever we see inside minus 1 cubed. What was inside? Well, it was the cube root of x plus 1. That was what we had inside. It was the cube root of x plus 1 we had inside, minus the 1. That's how f transforms anything. So when you combine these two terms, what do you get? You're left with the cube root of x to the power of 3. What is the cube root of x to the power of 3? X. That's what I gave you on the board here. So we say f of f inverse of x, we discover that this equals to x. That's a good thing. The second step is to prove that the other way around is also x. That means f inverse of f of x is also x. So this is f inverse of f of x is defined as x minus 1 cubed. We place f of x by its value. X minus 1 cubed. Then we're going to go to the inverse of the function to see how it's defined. The inverse of the function is defined as the cube root of x plus 1. The cube root of whatever you have inside plus 1. So this is going to be the cube root of whatever we have inside plus 1. What do we have inside? Well, it's x minus 1 quantity cubed. What is the cube root of this expression? X minus 1. So we're left with x minus 1 plus the 1 that was outside. You agree? And what does that give you? X. So we say, well, yeah, we did it right because we find the composition both ways is exactly x. That was part B. Number 28 is just like number 20. Same questions they asked you for number 20, they asked you for number 28. However, part B of number 28 is going to be very long. Okay? Because you have fractions over fractions. So be mindful of that. When we get to part B of number 28, if it's possible, please drop your pencil, pay attention because it will be better for you to do that. F of x is given as 2x minus 3 over x plus 1. That's the function that is given. Part A is to find its inverse. Well, the inverse, we use the 4 steps. The first step to get to the inverse is to replace f of x by y. this is what we'll do. The second step is to do what? Anybody?
Interchange X and Y.
Interchange them. That means change x into y and y into x. That's interchange them. The third step is to solve for y from the second step. Always recommended to write it like that. We write what you have on step number 2, so you can solve it, so you can solve for y. Whenever you have a fraction equals to another, you cross multiply to simplify. What does that mean? Well, you're going to take this one times this one, and this one times that one. Okay? That's how you're going to get rid of the fractions. So we said this is 1 times 2y minus 3 equals to x times y plus 1. At that, you would get rid of all parentheses to solve for y. This is 2y minus 3 equals to xy plus x. Now what you want all your y's together on the left because you're solving for y. That's what you're looking for step number 3. So that is 2y equals to x. Now you want to move the 3 and put it on this side, while you want to move the xy and put it on this side. What can you do here to find y? How would you find y here?
Divide.
You cannot divide yet.
You can factor that out.
You would have to factor first. Factor y out because it's in common. So you factor y out. Now you can divide because it is safe to divide to get y by itself. And that we find y equals to x plus 3 over 2 minus x. Since we get y by itself, we can say, okay, step number 4 is f inverse of x is x plus 3 over 2 minus x. That is the inverse of the function that they asked you to look for. As I said before, part B of this problem is going to be somewhat long because it's going to be fractions over fractions. Pay close attention to part B. Part B of this problem is the same as part B of number 20, but you can see that the functions are different. So this one is going to be a little bit longer. But it's the same question as part B of number 20. They ask you to find out whether or not what you claim to be the inverse is actually the inverse. How? Find the composition of the two functions, both ways. So for part B, we start by having f inverse of x and see if this is going to be x. That's what we're going to try to verify and see. This is f of, you replace f inverse by its value, which is x plus 3 over 2 minus x. That was f inverse. Now, we want to check and see whether or not, well, we want to find f of that expression. Well, be very careful now. How does f transform anything? Well, it's 2 times whatever you see inside, minus 3, over what you see inside, plus 1. So, this is going to be 2 times whatever you see inside, what you see inside here, minus 3. Well, since the 3 doesn't have any denominator, we just put a 1 underneath, over what you see inside, plus 1. But since the 1 has no denominator, I put a 1 underneath. I put those denominators because I know I'm going to need them to unite the fractions. I have to have the same denominator. What was inside? Well, x plus 3 over 2 minus x. That's what was inside. To be able to unite these fractions, because that's the only way to operate them, to unite them, I need to have the same denominator. What's the LCD here? 2 minus x. So that's what I need to have for each fraction that is involved. That means I need to multiply top and bottom here by 2 minus x. We all see that. Now I can combine the fractions because I do have the same denominator. So let's combine the fractions on the top. First, let's deal with the top. The LCD will remain 2 minus x. but when you multiply the 2 times everything on the top here, you get 2x plus 6. When you multiply the negative 3 times everything in here, you get negative 6 plus 3x. And then we go on the bottom. Since you have no coefficients here, the top will remain the same. So it will remain x plus 3. And the bottom, since we have 1 times everything inside, they will remain the same also. That's plus 2 minus x. And I think I said that in this class already, but let me just mention it again. If I were to give you 3 over 5 divided by 7 over 5, given that I'm dividing 2 fractions with the same denominator, I can simplify the 5s. At that, I will be looking at 3 over 7. Do we all see that? So that's the rule that we're going to apply here for these 2 fractions. Given that they have the exact same denominator, we cancel the denominators, and we just keep the tops. When you keep the tops, what do you have left on the top here?
2x plus 5x.
5x. What do you have left on the bottom here? What is that?
5.
5. What is that?
1.
X.
X. So this is f inverse of x is x. So we verify the first way is working out. You cannot stop here, you have to go the second way also. So let's go with the second way, where we're going to find the inverse of the function. The combination of the inverse and the function is x. So the second way is to prove that f inverse of f of x is also x. That is, f inverse of f of x is 2x minus 3 over x plus 1. Again, we have to go back to f inverse to see how it's defined. It is whatever you see inside plus 3 over 2 minus whatever you see inside. Whatever you see inside plus 3 over 2 minus what you see inside. So, this is whatever you see inside plus 3. Over 2 minus whatever you see inside. Now what we have inside is 2x minus 3 over x plus 1. 2x minus 3 over x plus 1. What is the LCD here?
X plus 1.
X plus 1. We try to get that for each fraction that is involved. From there, we can get rid of all parentheses and combine like terms. Combine the fractions together, which is what we'll do. LCD will remain x plus 1 on top. No coefficient here, so that will remain the same. However, 3 times everything in here would be 3x plus 3. On the bottom, x plus 1 will remain the denominator. 2 times everything in here is 2x plus 2. Observe that the negative times everything in here would negate everything inside of parentheses because of the negative sign. So we have negative 2x plus 3. For the same reason that we gave for the previous one, we'll do that for this one also. Same denominator, cancel them out, keep the tops. And also we'll combine like terms. What do we have on the top here?
5x.
5x. On the bottom?
5.
5. What is that? X. Okay, so we just proved that. The other way around also works. And that's what you were asked to do for number 28. Questions? Yes. Quite a few things to remember, and it's going to be like that for almost all the sections in this class, in this test. So we have to practice a lot. Okay? That was 28. 29 to 34, we're going to look at the graphs and we're going to say whether or not the graphs have inverse based on the horizontal line test that I gave you, the note that I gave you on the board. You're going to use the note that I gave you on the board to state whether or not numbers 29 to 34 have inverse. The graphs, whether or not they have inverse. 29. Does that have an inverse?
No.
No, because you can find a horizontal line that would cross it into 2 points. You see that? So it does not have an inverse. It does not have an inverse. How about 30?
Yes.
Yes. 31?
No.
No. Actually, you can find a horizontal line that would cross 31 in 3 points. So it's not, doesn't have an inverse. 32?
No.
No, because you have a branch that is constant. So a horizontal line will touch all these points on the branch that is constant. So therefore, it doesn't have an inverse. We say no for 32. 33?
Yes.
Yes. 34?
Yes.
Yes. So the only three that do not have inverse are what? Anybody?
The don't.
Do not have inverse.
29, 31, 32.
Wonderful. Okay, 29, 31, and 32 do not have inverse. Okay, and they were only yes or no questions. Okay, but I just want to make sure that you know why we say yes, why we say no. That's why we explain it. All right. Any questions about that? $36. For number 36, the question is to graph the inverse of this graph that they gave you. They gave you a graph, and they asked you to find its inverse. First thing to do, pull out all the points down the current graph. Let's call it f of x. Let's pull out the points on f of x. Reading the graph from left to right. Anybody? What are the points?
Negative 3, 0.
Negative 3, 0.
Negative 1, 2.
Negative 1, 2.
And 5, 3.
And 5, 3. These are the points on f of x. Now, let's give the points on the inverse. The points on the inverse will just interchange the place values. That's all. Interchange them. That's how you find the inverse when you're giving a point. Interchange. Meaning what? Anybody?
Positive 3. Right?
No, interchange. Interchange them.
0, negative 3.
0, negative 3. Next.
2, negative 1,
2, negative 1. Next.
3, 5.
3, 5. Thank you. These are the points that you're going to have to plot, and that's what will be the inverse of this graph that is given. Okay? So let's plot those points. We need 1, 2, and 3. We need 1, 2, and 3. 1, 2, and 3, and 4, and 5. Okay, first point, 0, negative 3, is this one. I closed this one here because that's what they gave me on the original graph. The very first point was a closed point. It was not extended. Do we all see that? However, the last point was extended, so I'm going to do the same for the inverse. This is close. 2, negative 1 would be this point here, 2, negative 1. And finally, 3, 5. So I'm going to connect these points together, and remember now to extend the last one past the point, because that's the way that the graph was. So that would be the graph of f inverse. Any questions on how we graph the inverse? Number 42, you asked to do several things. So let's take them one by one. Given the function f of x equals to 2x minus 3, You ask first to find its inverse. Well, we go to 4 steps. What's the first step?
That's not 42.
Back to one.
It's number 40. It's the
That's
correct
40.
problem though.
Hold on. Did we say 40 or 42?
40. It's the correct problem.
I got 42, but it's, yeah, it's supposed to be 40 that we altered. We replace f of x by y, so this is 2x minus 3. The second step is to do what?
Inverse x.
And to change them, right? And to change them. So that's x equals to 2y minus 3. What's the third step?
Solve for y.
Solve for y from number 2. That means we copy number 2. And then from there, solve for y. What we'll do, we'll put the 3 on this side to get y by itself. So it's x equals to 2y. And you move the 3 to put it on this side, it becomes positive 3. What would you do here to get y? Divide everything by 2. 1 by 1, divide them by 2. At that, it would be safe to say y equals to 1/2 of x plus 3/2. So we can write the inverse of the function to be 1/2 of x plus 3/2. That is the inverse of the function that they asked you to come up with. Any questions so far? Part B is to graph the function and its inverse. You ask to graph both of them, the function and its inverse. Graph them. Okay, so let's come up with the graphs of f and f inverse. Now let's make sure that we understand something now. Whenever you see f of x, this is just like you saw y. Agree? So they gave you this function here as y equals to 2x minus 3. What is the slope of this line? Anybody? 2. We can say 2 over 1, right? What is the y-intercept? 0, negative 3, that's what you said, right? Good. What is the slope of this one here? Let me write it in red. What is the slope of this line here? 1/2. What is the y-intercept?
0.
Good. My good friend said 0. Make sure you said it. Anyway. So part B is to graph that mess using these information, okay? So let's do that. 1, 2, 3, 4. 1, 2, 3, 4. Do you have any negative slopes? No? Y-intercept -3. 1, 2, 3. Let's first graph the function. Y-intercept 0, negative 3 is here. The slope being positive, you go up or down? Up. How many units?
2.
2. From the y-intercept, you go 2 units up. 1, 2. How many units over? 1. So these are the 2 points that are on f of x. And we're going to connect them together, and that will be the graph of f of x. Is that the only way to graph it? No, but that's one way. Okay? That's one way. Next, we're going to graph the inverse. 0, 3/2, which is 1.5. Okay? 3/2 is 1.5. So it's going to be here. That's the y-intercept. The slope being positive, you go up or down? Up. How many units?
1.
1. You go up 1 unit and over how many?
2.
2. So the point is somewhere there. Seems like they're intersecting each other. Nope. It's a little too far like that, I guess. So now you connect the 2 points. And that's f inverse of x. Now, part C is to find the domain in the range of each one of them. Now, looking at the graph, what are the x values that are covered? Is everything covered by this line here? If it's a line, all the x values will be covered, right? Because it has a slope here, positive slope, so it's extended, doesn't have any endpoint. So the domain for f, we agree, is all real numbers. Now, based on the note that we said here that the domain of one is the range of the other. If we know the domain of f, we know the range of the inverse. So we say the range of the inverse is also all real numbers. Because domain of one is the range of the other. The range of f, since it will cover all the y values, you see the green graph, it covers all the y values, then we say the range is all real numbers. So the range is all real numbers. Which would say that the domain of the inverse is also all real numbers.
What's the situation that it wouldn't be all real numbers?
You will see, we have another problem. For that same set of problems, we have another one that will explain that, okay? It's coming up next time. We'll see you next.